Okay, hello dear friends, good afternoon, such a beautiful, beautiful afternoon. Now we do question 11. It takes me so much, I will show you how much work. Why? You can see I draw so much to do it. So I will move this picture to a new place. You do not need to see it. You do not need to see all my hard work. We will start from a new page. How about that? Okay, I put it here. Now let's take a look of this problem. Question 11. Graph one cycle of y equal minus 3 sine a quarter of x minus pi over 8 plus 5. So you need to know amplitude, vertical shift, and the number of cycles between 0 and 2 pi's, and period, and phase shift, and scale, and all these things. So first, we will copy this problem in blue pen. Y equal negative 3 sine a quarter of x minus pi over 8 plus 5. If we say it too quick, first, my little brain cannot sustain it. Second, it becomes very complicated. So we do several steps. First, the mother generation of this function, y equal to sine x. That is easy peasy we can do, right? 0, pi, 2 pi. Every 2 pi is a full cycle. 1, negative 1. So these are the points it will go through. This is the very original. Okay, now we do the second step. Y equal to sine 1/4 of x. So how long it make a shift? You need to time 4. So every 8 pi, it is 1 cycle. So this, instead of pi, it will become 4 pi. And this, instead of 2 pi, will become 8 pi. It's like this. And still the top is 1, the bottom is negative 1. I will erase this. This does not look good. And here, sorry. And here is 1 dot, here is 1 dot. So this, instead of pi, this instead of pi is 4 pi. This instead of half pi, it will be 2 pi. So this is our second graph. Sorry, yeah, it's not so good drawing. Okay, please forgive me. Now, step number 3, y equal sine a quarter of x minus pi over 8. So we need to shift a little bit. Where do we shift? We shift to the right. When everything becomes 0, the x is actually need to be here. When x is 0, the whole value is actually, when this is 0, it starts from here. This is pi over 2. This is pi over 2. Pi over 2 or pi over 8. When x is 0, when x is 0, when x here is 0, x is yes. So it starts from here, and this is 4 pi plus half pi, and this is 8 pi plus half pi. So this is the graph. 1, 1, negative 1. Okay. Now, step 4, y equal negative 3. Sign the same. 1 over 4x minus pi over 8. So it's actually make it much thinner. How thin it? It times 3 times. And it's negative, it goes down. And okay, I will use another color pen to write. It starts always from here. Instead of negative 1, it will be negative 3. Instead of positive 1, will be positive 3. And because here is negative, so it goes just the opposite. Okay, this is a new step 4. Now we go to step 5. Step 5. We come to the end of it. Negative 3. Sine 1 over 4x minus pi over 8. And this one plus a 5. Did you see? You need to plus 5. Plus 5 means you shift everything up 5 blocks. So here we have the same graph. We work on the same graph, okay? Shift 5 block. So when it is 0, it will be 5. 1, 2, 3, 4, 5. When it is negative 3, it will be positive 2. I use a red pen to do it, okay? When it is 0, it will be this 0. When it is a positive 3, it will be positive 8. Zero, 1, 2, 3, and 0. So it will be like this. Not in that graph. Okay. So it will be not even touching this graph. 1, 2, 3, 4, 5, 6, 7, 8, 6, 7, 8. And this is pi over 2, starting from here. The lowest point, starting from 5, no, from 8, starting from 5, do it again. Starting from 5, pi over 2, and every 4 pi plus pi over 2, 8 pi plus pi over 2. This is pi over 2, 4 pi pi over 2, 8 pi pi over 2. Gosh. Goes from 8, starting from 5 to 2, go up until reaching 8, and that is our graph. This one, this cinema-jinger is our graph. It goes very much off the chart. Whew. Okay, I will go to decimal to prove if I am correct. I have no confidence with it. It's just too complicated. Thank you very, very, very much. I love you. I really do. Do. Okay, to prove if our graph is right, so we need to figure out these critical points. I use a green one. So it starts at, use a green one to write, starts at when x equal to pi over 2, y value will be 5. And if we transfer it into number pi 3.141.575, this is one critical point we will absolutely need to remember. And the lowest point will be x will be 2 pi plus 2 pi plus half pi, so it's 2.5 pi, and 2.5 times 314 times 2.5, or 乘以2除以2除以2 1.57乘以5 OK 1.57乘以5 5 7 35 5 5 25 28 15得5得7 So this point will be 7.85 and the value of y will be 2. Okay, and this point will be 4 pi plus 3.14乘以4 4 pi yes 3 4 4 16 14得4得5 12 12.56加 1.57 3 1 14.13 and this one is 5. Yes, and this one will be 6 pi plus 2 6 pi plus 1.57 6 3.14乘以6 4 6 24 14 16得6得8 3 6 18 1.57 1 4 0 20.41 and the highest 8, and this one will be 8 pi and plus 6.28 9 8 26.89 26.89 and the y0 will be 5. Okay, let's take a look, and these are the numbers we need to check. If we get this number, our graph is right. I am so excited. Okay, let's check it out. I put in that graph function, the quadratic, not quadratic. We put in that trigonometry function. I'm sorry, when I am too focused in thinking, my language does not follow up. Please excuse me. -3 times sine 1 over 4x minus pi over 8 plus 5. So let's look for these points. And we have a point 1.57 and 5. Let's 1.57 and 5. Let's go to look on our graph. Y equal to 5, expanded. Y equal to 5. Y equal to 5 here. Oh my goodness. 1.571. Did you see it? Did you see it? I was right on point 1. I am right on point 1. Okay, point 2, let's take a look. 7.85 and 2. Okay, let's look for it. X value, Y value is 2. This point, 5 pi over 2. 5 pi over 2. Let's do the division. 5 pi divided by 2. 5 times pi divided by 2. Oh my goodness! 7.85 and 2. We are right. 7.85. Okay, let me move. Oh my goodness! 7.85 and 2. Okay, let's keep on 7.85 and 2. And this one, 14.13 and 5, 14.13 and 5. Let's go to look for 5 here. Oh my goodness, look at it. We are almost there. Even bigger, even bigger. Let's see. 14.13 and 5. Look at my calculation. 14.13 and 5. 14.13 and 5. And this one, 20.41 and 8. 20.41 and 8. Let's look for 8 here. Oh, 13 pi divided by 2. 8, we have seen 8. Now 13 pi divided by 2. Let's see how much is it. 13 pi divided by 2. 13. 1, 3. Oh my gosh. 20.42. Let me see. Face. I'm here. Okay. 2041. Oh my gosh, 2041, 2042. It will be roughly the same. 26.89 and 5. 26.89. Okay, let's look for it. I am so happy. 1, 2, look for 5. Yeah, here. No, this one, 20. Oh my. 3, 4, 5. Oh, this is a 6. Oh my. Move it bigger, bigger. This is 5. 26.7. Okay. 2689. There might be some calculation mistake. Or 69. I wrote it down. 2669. Anyway, I am right. I am so happy. So happy. So happy. Finding, and I totally forgot this geometry, these trigonometry things, and I'm not very good at. But as you can see, if you use logic, if you use reasoning, even if you do not remember the formula, you can figure out something. And it is better that you remember the reasoning instead of the formula. Eventually, you can always get to the right answer. If our life is only about taking a test, we could be a big-time failure. But if we focus our life on understanding the real thing, we may not be that bad. As I heard a lot of scientists, mathematicians, they were regarded as slow students. It may be their way of thinking takes longer time. They do not remember the formulas, but they think deep. We are not bad at it. We are just different. I love you. I really do. Do. Bye-bye, friends. Such a wonderful feeling. Bye-bye.